arbitrary constants. So order is nothing but number of arbitrary constants. Here A and B are two arbitrary constants are there. Then we can write A is and B means order is 2. Order is 2. And whenever equation of curve is given, then form the differential equation of differential equation is asking. So we have standard results are there. Already I have told just now standard results. So whenever equation of curve is there, look like then this differential equation of this one is d square y by dx square minus 2 alpha into dy by dx plus alpha square into y equal to 0. So compared to this, now alpha means what here 5 and alpha value 5. So substitute in this we are getting what? D square y by dx square minus 10 into dy by dx plus 25 equal to 0. This is the whenever equation of curve is given, form the differential equation means you can do like this. And order is asking, we should observe what are basically 2 points, Nana. So one point is whenever equation of curve is given, then find order is asking, we should observe how many arbitrary constants are having that curve, then immediately you can say order is equal to 2. How many arbitrary constants are there? 2. So 2 means A and B are two constants are there. Arbitrary constants are there. Order is 2. So whenever equation of curve is given, then form the differential equation means we have standard results. So then compared to this, we have alpha equal to 5. Then substitute in this, we are getting this. And one more example. See here, one equation of curve is given, then form the differential equation. How to do? See, xy equal to continuation number, xy equal to form the differential equation of this one is xy equal to a into e power x plus b into e power minus x plus x square plus x square is given. This is the equation of curve. So whenever equation of curve is given, then form differential equation means first we should observe what? How many arbitrary constants? See, here A and B are two arbitrary constant. Order means whenever one equation of curve is given, then order means you can write directly order is equal to. How can you know? Just based on arbitrary constants. So form the differential equation means we should eliminate A and B. So first I am doing here xy equal to xy minus x square equal to a into e power x plus b into e power minus x. This x square I am sending to here. Now differentiate with respect to x. Now this is UV form. Whenever two functions are in product is there, we should do what? UV form. So x into d by dx of y is nothing but y1. Now plus y into d by dx of x value is 1 minus 2x. That equal a into e power x derivative is e power x only. Now minus b into e power minus x. How can I write e power minus x? Means d by dx of, listen carefully. Now d by dx of e power x formula is e power x in first year derivatives. Now d by dx of e power minus x means here minus x we should consider as x. We should take an as what here x. If you are taking the total minus x is taken as x, then it is in the form of this e power x only, e power minus x. Again, internal derivative of this x is nothing but minus 1. So it can be written as minus e power minus x. So that's why here plus into minus minus. Now again I am writing. So x into y1 plus y minus 2x that equal to a into e power x minus b into e power minus x. Now again again differentiate with respect to x. See, listen, Anna, one more important point. I forgot. See, so whenever differential equation, whenever one equation of curve is given, then find the order means two arbitrary constants. So based on arbitrary constants only, we should differentiate this given curve. So here, how many arbitrary constants are there? Two is there. So indirectly, this equation we should derivative how many times? Two times. So first derivative we are getting this one. Again, derivative differentiate with respect to x. Again here uv. Now x into y1, y2 plus y1 derivative dy by dx. After derivative, we are getting what? dy by dx of y1 is nothing but what? Y2 plus y1 into dy by dx of x value is 1 plus y1 minus 2 equal to a into e power x plus b into e power minus x. Now x y2 plus y1 plus y1 means 2y1 minus 2 equal to, in place of this, can I write what here? In place of that from equation 1, xy minus x square. The total terms into here, x into y2 plus 2y1 minus 2 minus xy plus x square equal to 0. So it is a differential equation. So whenever one equation of curve is given, order means directly you can say how many arbitrary constants are there. We should identify. Then you can say order is 2. Here two arbitrary constants are there. We can say 2 only. So whenever equation of curve is given, then form the differential equation. Means that time we should do what? We should eliminate two arbitrary constants A and B. After eliminating, we are getting this. This is the standard differential equation. You can write like this, or in terms of dy by dx means x into d square y by dx square plus 2 into dy by dx minus 2 minus xy plus x square equal to 0. Okay. So one equation of curve is given, form the differential equation means you can do like this. So depend on arbitrary constants, we should derivative of that equation. For example, here two arbitrary constants are there, we should derivative two times. Then after evaluating this given curve, we are getting what here? One differential equation of the form. Okay. So one more question. Yes. See, listen Anna, carefully. So whenever one equation of curve is given, form the differential equation is asking, first we should observe how many arbitrary constants are there, we should identify. So directly order is asking, just based on arbitrary constants, directly you can write order is 2. And form the differential equation is asking, we should eliminating two arbitrary constants, means indirectly we should derivative how many times? Two times. So this is the first derivative, we are getting this. And second order, again derivative with respect to x, we are getting x into y2 plus y1 into x derivative is 1. This is y1. So divide x of x value is 1. And 2 into 1 is nothing but minus 2. And a into e power x derivative is e power x minus b into e power minus x after internal derivative. So that part already I have told just now. So plus b into e power minus x. So instead of this, we don't want AB, arbitrary constant. After evaluating this given curve, the differential equation should be eliminating what here A and except to A and B terms. So here nothing, A and B terms are not there. So it is a standard differential equation of the given curve. Okay. Now coming to one more question. So basically order and degree means order is nothing but highest derivative of a given differential equation. That is what order. And the degree means what here we should observe 2 points, major important 2 points. So 1 point is that equation should be a polynomial equation in derivatives. If it is a polynomial, it is okay. We should calculate order and degree also. And whenever a derivative is having a derivative, see, derivative should not have function of trigonometry or exponential or logarithm is there. So that time we cannot find out what a degree. So that is not defined. So whenever one equation of curve is given, how to write a differential equation forms already I have told just now. So that 5 standard formulas are there. That 5 is very, very important. You can learn that 5 points. And whenever one equation is given, then we should identify how many arbitrary constants are there. Then we can calculate, then simplify, we are getting this answer. So this is what here, whenever one equation of curve is given, see, this is order and degree. Order and degree definitions completed and examples also completed, and in EAMCET and mains also, just you have to learn and keep in your brain only 2 points. Order means highest derivative of given differential equation is a order, and highest derivative of powers our exponent is called degree. In this case, we have 2 points. It is a polynomial or not. If it is a polynomial, then we can write as it is. If it is not a polynomial, means we should convert the polynomial or not. How can you decide that power or fraction form is there? We should convert to natural forms, natural number form. Okay. So this is order and degree based on problems. Now variable separable based on problems. Variable separable based on problem. See, a differential equation of the form, already I have told definition in previous class only. A differential equation of the form dy by dx equal to f of x by g of y is given. So variable and separable. In sentence, variable separable means we should convert what? All x terms one side, all y terms one side, then integrating on both sides, then we are getting answer. That is what here variable separable. So I can write here. Now 1 by g of y into dy equal to f of x into dx. Just I am doing whenever a differential equation of the form dy by dx equal to f of x by g of y is given. Then variable separable means what? All y terms here. In LHS only y terms. In RHS only x terms. Now we should do what? IBS means integrating on both sides. Now integral of 1 by g of y into dy, that equal to integral of f of x into dx. So this is the procedure. Okay. So based on variable separable, we have to do one or two questions. So write one question. One question. See, the solution of dy by dx, the solution of dy by dx, 1 minus y by 1 minus y by 1 minus x. This is the NCERT book problem, this one. So dy by dx equal to 1 minus y by 1 minus x. So variable separable means what? Just we should do what? All x terms, all y terms take one side. See, now I'm writing 1 by 1 minus y into dy, that equal to 1 by 1 minus x to dx. See, observe here. Based on given differential equation, we should convert what? Variable separable form means all y terms, all x terms. Then immediately we should do what? Integrating on both sides. Integrating on both sides. Now integral of 1 by 1 minus y into dy equal to integral of 1 by 1 minus x into dx. Here 1 plus here plus y is there. We can write the total y value. The total 1 minus y is taken as 1 plus y means we should taken as what? Y. So integral of 1 by y means before that integral of 1 by x into dx, what formula is? Log x. Log x plus c. So whenever negative symbol is there, we should try to keep it in bracket before integral before minus log of 1 minus y equal to here also minus log of 1 minus x. So both LHS and RHS are having in terms of log. So C also you can write in terms of log C. Now I can write log of 1 minus x minus log of 1 minus y equal to log C. Here minus log of 1 minus x and take it in LHS, we are getting this step. So after this, log, this will look like what? Log A. This is what here? Log B. Log A minus log B can be written as log A by B means 1 minus x by 1 minus y, that is equal to log C. Now both the log terms will be cancelled. We are getting 1 minus x by 1 minus y equal to c. So this is the solution of this differential equation. So once again, listen Anna, carefully. So whenever a differential equation is given, dy by dx is equal to 1 minus y by 1 minus x, then variable separable means what here we should write x terms and y terms. Take it x terms one side and y terms one side. Then after that, we should do what? Integrating on both sides. Now integral of 1 by 1 minus y into dy, integral of 1 by 1 minus x into dx. So 1 plus y is there, the total y is taken as y only. But any value, y is sometimes, here y is having negative sign means you should write negative. For example, here 2 is there. 2 means what? You can write 1 by 2. 3 is there, you can write 1 by 3. So based on what? Substitution method. Method of substitution in integration, already we discussed about a method of substitution. Based on only, we should write directly minus log of 1 minus y equal to minus log of 1 minus x plus both are having log terms. That's why constant also you can write log c only. That negative terms I am sending to LHS. Log of 1 minus x minus log of 1 minus y equal to log c. This is look like log A minus log B can be written as log A by B, that is equal to log C. Log is cancelled. We are getting 1 minus x by 1 minus y equal to C. So one more question. The solution of the solution of the solution of y dx, the solution of y dx minus x dy equal to 0. Y dx minus x dy equal to 0. See here, we should do what here? The solution of this one, we can write first variable separable means y into dx equal to x into dy. Okay. Now variables here, y function and x function is there. Here also x and y is there. So we should write x terms and y terms separately. Now what you will get? 1 by x into dx equal to 1 by y into dy. So this is the x terms, this is also y terms. So then we can do what? Integrating on both sides. Integral of 1 by x into dx equal to integral of 1 by y into dy. So integral of 1 by x into dx means what? Log x equal to, this is what here? Log y plus you can write constant, take it in LHS or RHS, your wish, no issue. So log c. Now log x equal to log a plus log b can be written as log a into b. Now log is cancelled. X is equal to what? X is equal to c into y. So this is a variable separable based on solution, this one. Okay. One more question, third question. The solution of dy by dx equal to the solution of dy by dx equal to 1 plus y square by secant square x. The solution of 1 plus y square by secant x. So by using variable separable, we should do what? Variable separable means all y terms. Means can I write 1 plus y square into dy that equal to 1 by secant x into dx. So now IBS integrating on both sides, integral of 1 by 1 plus y square into dy, integral of C. In entire integration 1 by secant x we don't have formula. That's why I can write reciprocal of secant, I can write cos x into dx. So this is standard formula. Integral of 1 by 1 plus x square into dx is tan inverse of x. So I can write here y terms is there. So tan inverse of y equal integral of cos means sin x. So after completion of integration, you have to write C. So this is the solution of this differential equation. Now one more particular solution based on one question. Now question number 3. When x is equal to 0, and y equal to -1, when x is equal to 0 and y equal to -1, the particular solution of differential equation, the particular solution of differential equation 1 plus y square into dx plus dx plus 1 plus y square into dy equal to 0. So particular solution means after getting answer should be have without c term. See, how can I write? Listen carefully. First, by using this one, we should convert to differential equation form means the dy by dx form. Now I am writing 1 plus y square into dx equal to minus of 1 plus x square into dy. Now 1 by 1 plus x square into dx that equal to 1 by minus 1 by 1 plus y square into dy. Okay. Now here only x terms, here only y terms. Then we should do what? Integrating on both sides. Now integral of 1 by 1 plus x square into dx that equal to minus take outside 1 by 1 plus y square into dy. So this is a standard formula, tan inverse of x. This is what a tan inverse of y. So here both terms in LHS and RHS in terms of tan inverse is there. You can write a constant C also in terms of C, tan inverse of C. Now this minus is I'm sending to LHS, tan inverse of x plus tan inverse of y equal to tan inverse of C. See, in LHS from inverse of trigonometric functions, tan inverse x plus tan inverse of y means tan inverse of x plus y by 1 minus x into y that equal to tan inverse of C. So both the tan inverse should be cancelled. Now x plus y by 1 minus xy equal to C. So here x is equal to 0 and y equal to -1 is given. Substitute in this. Now 0 minus means -1 by, this is taken as equation 1. Now in place of x 0 here, in place of y -1, substitute in this, we are getting 0 minus 1 is -1. So 1 minus 0 means what here? 1, that equal to C. Now C equal to -1. Now equation 1 becomes means this C value substitute here. X plus y by 1 minus xy equal to 1, or x plus y equal to 1 minus xy. This xy sent to here. X plus y plus xy equal to 1. So this is the particular solution of this differential equation. So whenever sometimes x and y values are given, one differential equation is given, then particular solution of or general of particular solution is asking, we can do like this. Okay. Now coming to one more question. Yes, I hope all of you understood. Listen and carefully. Basic concepts is very important. You know concepts, you can do very easy MSET level and mains and advanced. Everything is totally depend on definitions and formulas. You know definitions and formulas, you can do very easy MSET. You know MSET problems, you can do mains and advanced also. So depend on basic concepts and definitions only very important. Okay. So we can do one more question, Anna. So one question is in variable separable based on one more question. Yes, the solution of 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 dy by dx, the solution of dy by dx, the solution of dy by dx, the solution of dy by dx plus y into tan x, y into tan x equal to 0 is given. So this problem also based on variable separable. So first we should write here dy by dx equal to minus y into tan x. Now I can do here minus 1 by y into dy equal to tan x into dx. Tan x into dx. Now we should do what? Integrating on both sides. Okay. Now minus take outside. Now integral of 1 by y into dy equal to integral of tan x into dx. Now integral of 1 by x into dx is what? Tan log x. But in terms of y is there. So I can write log y equal integral of tan x means log mod secant x. Plus both are having log terms. So you can write c also log c. Now minus log y equal to, or you can write this one. Okay, right. Minus log y equal to log a plus log b. Can I write log a into b means c into secant x. So log y whole to the power of minus 1. This before the log value will come here, power of the y function, that equal to log of c into secant x. Now both the log terms will be cancelled. We are getting 1 by y equal to c into secant x. This is the solution of this problem. Okay. So variable separable based on these questions. Okay. Now coming to homogeneous differential equation. So already I have told homogeneous differential equation. Homogeneous differential equations. Homogeneous differential means a differential equation of the form dy by dx equal to f of x comma y by g of x comma y. In this numerator and denominator both are in terms of x and y. At the same time, degree is same. So for example, so based on homogeneous differential equation, just example problem. See, dy by dx is equal to x square plus y by 2x square. Now, it is a homogeneous differential equation. At the same time, degrees equal to, degrees how much here? 2 is there. In denominator also, degrees 2. Okay. So, a differential equation of the form dy by dx is equal to f of x comma y by g of x comma y, where f of x comma y and g of x comma y are in functions of x and y. At the same time, degrees should be equal. So in this, we have two cases. Already have told two cases. The first case is dy by dx equal to f of x comma y by g of x comma y is given. Then working rule for case 1 is working rule. Put y is equal to vx. Put y equal to vx. Now here differentiating with respect to x. Now dy by dx equal to v plus. Here v is a function. X is also one more function. Whenever two functions are in product is there, we should apply UV rule. Means in first differentiation, u into d by dx of x means 1. I am not writing here 1. V plus x into dv by dx. You know these two values substitute in this. After doing variable separable, then integrating on both sides, we are getting solution of this. I can explain one problem also based on case 1 and case 2. Case 2, dx by dy equal to f of x comma y by g of x comma y is there. G of x comma y. It is a homogeneous differential equation. But here dx by dy, we should take what? Put working rule. Put x is equal to vy. Now differentiate with respect to y. Now dx by dy equal to v plus y into dv by dy. So now using these two conditions, substitute in a given differential equation, then simplify after doing variable separable, then integrating on both sides, we are getting answer. Now based on homogeneous differential equation, we can do case 1 and case 2 some problems, right? One question. Right, one question. Homogeneous differential equation based on one question, right? Yes, based on homogeneous differential equation, write one question. The solution of differential equation, x square into dy plus x square into dy plus x square into dy plus y into x plus y. Y into x plus y. Y into x plus y. Y into y into x plus y. Y into x plus y. Y into x plus y into dx equal to 0. Now here x square into dy equal to minus y into So I can write here. We should convert to dy by dx or case 1 or case 2 form. You should write. Now here denominator I can write this one. Y into x plus y into dx, that equal to minus x square into dy. Okay. Now xy plus y square into dx, that equal minus x square into dy. Now dx by dy equal to minus x square by xy plus y square. Okay. See, it is a homogeneous differential equation. At the same time, degree also same. Now here dx by dy means we should take put x is equal to vy. Okay, this is taken as equation 1. Now differentiate with respect to x. Now 1 is equal to v into v plus y into dv by dy. Okay. Now equation 1 becomes, so in place of dx by dy, can I write what? V plus, this is what dx by dy, na? Dx by dy with respect to c, y. D by dx means with respect to, differentiate with respect to y. Dx by dy equal to v plus y into dv by dy. Now equation 1 becomes, in place of dx by dy, I can write v plus y into dv by dy, that equal to, so in place of x we can write minus v square y square by, now x means in place of x vy means v into y square plus y square. Now v plus y into dv by dy, that equal to, now here minus v square y square by, here y square is take common. Now v plus 1. Now v square is cancelled. V plus y into dv by dy equal to minus v square by v plus 1. Now variable separable means all v terms is taken as one side. Now I am writing y into dv by dy, that equal to minus v square by v plus 1 minus v. Now y into dv by dy, that equal to minus v square minus v by v plus 1. Now y into dv by dy, that equal minus 2v square minus v by v plus 1. Now we should do what? Variable and separable. After that, variable separable means v plus 1 by 2v square minus plus v and that equal into dv equal to 1 by y into dy. 1 by y into dy. Now we should do what? Integrating on both sides. Now integral of v plus 1 by 2v square plus v. So equal to dv into dv equal to integral of 1 by y into dy. See, in RHS we have standard formula. So first if we can write here separately here. Now integral of v by 2v square plus v into dv plus integral of 1 by 2v square plus v into dv equal to integral of 1 by y. So we have here v is take common. V by, I can write 2v square means v is take common 2v plus 1 into dv. Now plus integral of 1 by 2v square plus v into dv equal to integral of 1 by y into dy. So v's get cancelled. I can write f dash of x means multiplying and dividing with 2 here. Now 2v plus 1 into dv. So here I can write integral of 1 by root 2 into v whole square plus 1 square into dv equal to integral of 1 by y into dy. So this is f dash of x by f of x means log f of x. This is integral of x square plus a square is nothing but 1 by a tan inverse of x by a plus c. In RHS is the integral of 1 by y is nothing but log y. So both are in LHS and RHS are having in terms of log is there. You can write c is also log c. So the total this term sent to LHS log a plus log b, log a plus log b plus log c can be written as log a into b into c. Then log terms will be cancelled. We are getting the solution of this one. Okay. Yes, coming to one more question. See, now homogeneous differential equation based on one question is completed. Now coming to one more question. So the solution of dy by dx, the solution of dy by dx equal to 1 equal to x plus y by x minus y. A differential equation of the form f of x comma y g of x comma y is called a homogeneous differential equation. We have two cases. Now dy by dx is there. We should take a working rule is case 1. Now I am taking put y equal to vx. Now differentiate with respect to x. We can write dy by dx equal to v plus x into dv by dx. Now equation 1 becomes in place of dy by dx. I can write v plus x into dv by dx that equal to x plus vx by x minus vx. Now v plus x into dv by dx equal to x is take common 1 plus v by x into 1 minus v. Okay. So x is cancelled. Now x into dv by dx that equal to 1 plus v by 1 minus v minus v. Now I am writing x into dv by dx. X into dv by dx equal to 1 plus v, take LCM then multiply, minus v plus v square by 1 minus v. Now plus v minus v is cancelled. Now x into dv by dx equal to 1 plus v square by 1 minus v. Now variable separable means 1 minus v by 1 plus v square into dv that equal to now 1 by x into dx. Now we should do what? Integrating on both sides. See, already we discussed just now. Variable separable means all x terms, all y. But in this, v terms and x terms are there. So after doing integrating on both sides, integral of 1 minus v by 1 plus v square into dv equal to integral of 1 by x into dx. Now, direct formula is not possible. I can write integral of 1 by 1 plus v square into dv minus integral of v by 1 plus v square into dv equal to integral of 1 by x into dx. Now integral of 1 by 1 plus x square is look like what? Integral of 1 by 1 plus x square is tan inverse of x. Now tan inverse of x means v here minus c. I can do here multiplying and dividing with 2. If you are doing multiplying and dividing with 2, that is look like integral of f dash of x by f of x means log f of x means log of 1 plus v square equal to log x. So plus constant you can write c, log c. So after evaluating this integral function, we have to substitute back value of t means back value of v is nothing but in place of v I can write nothing but y by x. Now y by x minus 1 by 2 into log of 1 plus y square by x square equal to log x plus log c. So this is the solution of this problem. So it is a homogeneous differential equation. Yes, now non-homogeneous differential equation. So non-homogeneous differential, a differential equation of the form dy by dx, non-homogeneous differential equation. Non-homogeneous differential equation, it is in the form of dy by dx equal to ax plus by plus c by a1x plus b1y plus c1, where a comma b comma c and a dash a1 and b1 and c1 are constants. Okay. So in this we have three cases. Now case one. So whenever a non-homogeneous equation is satisfied one condition, b is equal to minus a1. So based on this condition, we can do one method is there. And case two, a non-homogeneous equation is given, we can do. So b is equal to minus a1. b1 is not equal to minus a1 comma a by a1 equal to b by b1. So that time we can do one method, put ax plus by equal to some t or v. So based on question we should do. I can explain each case one problem. And case three. Now case three. So put, I means here, case three is b is not equal to minus a1 and a by a1 plus not equal to b by b1. So whenever one non-homogeneous equation satisfies the first this condition, that is case one, we can do cross multiplication method only. And second case is b is not equal to minus a1 means we have two possibilities, case 2 or case 3. So case 2 is how can you know a by a1 equal to b by b1 is there. Immediately we should take some repeated term is there. That time we can write t or v, then derivative, then variable separable, then we are getting answer. And case 3 is b is not, both conditions are not equal is there. We should do working rule, put small x is equal to capital X plus h and small y equal to capital Y plus k, and dy by dx. Capital dy by dx is equal to, sorry, small dy by dx equal to t into capital d into capital Y by d into capital X. So after substituting a non-homogeneous equation, we are getting answer. Now based on each case one question. Right, one question. Right, one question is the solution of the solution of dy by dx, the solution of dy by dx equal to x minus 2y plus 3 by x minus 2y plus 3 by 2x plus y, 2x plus y minus 5 minus 5. See, it is a non-homogeneous equation. Just to see, observe here. Homogeneous and non-homogeneous means with constant, that is a non-homogeneous. Without a constant, with the constant means non-homogeneous. Without a constant is what a non-homogeneous equation, and degree is also same. Degree is here 1. Numerator degree is 1. Denominator degree is also 1. Now first we should write here a equal to 1 and b equal to minus 2 compared to non-homogeneous equation, and c is 3 and A1 equal to 2 and B1 is equal to 1 and C1 is equal to -5. So we have to observe here first condition what B is equal to minus A dash. B equal to minus A1 is possible or not possible? First we should observe. B equal to what here? 2 is there, -2 equal to B dash is not A1 is nothing but -2. So both LHS and RHS are equal. Means we should do what? This is the first case. In non-homogeneous first case. Then working rule what? How to do procedure? Now dy by dx equal to x minus y plus 3 by. So in place of b, you can write minus a1. A1 is value is what here 2 only. 2 means what here x minus 2y by 2x plus y minus 5. Then you should do what? Cross multiplication. We should do what? 2x plus y minus 5 into dy equal to x minus 2y plus 3 into dx. Okay. Now IBS integrating on both sides. Now integral of 2x into dy plus y into dy. See, I am writing individual. I am writing integral of 2x into dy plus integral of y into dy minus 5 is take outside integral of dy. So this total RHS I am sending to LHS minus integral of x into dx plus 2 into 2y into dx. So minus 3 into integral of dx equal to 0. Equal to 0. Now integrating on both sides. Now what you will get now? Now integral of, okay, integral of 2 take outside x into dy plus y into dx. Okay, these two terms taken as one bracket. Now plus integral of y into dy, integral of y into dy minus integral of x into dx minus 5 into integral of dy. So minus 3 into integral of dx equal to 0. Okay. Now this is taken as one of the property derivative of x comma y. This is a formula for one property. Now plus integral of y into dy minus integral of x into dx minus y into 5 into dy minus 3 into integral of dx equal to 0. Now derivative and integration is already the reverse process of differentiation is called integration. Okay. Then what you will get now 2xy plus y square by 2 minus x square by 2 minus 5y and minus 3x equal to 6. Here take LCM is 2. Now what you will write 4xy plus y square minus x square minus 10 minus 10y minus 6x equal to c. You can write order wise y square plus 4xy. Okay. Y square plus 4xy minus x square minus 6x minus 10y equal to c. So this is what here whenever a non-homogeneous differential equation is given, first we should observe here first case condition is b is equal to minus a1. Then all values substitute in this. Then if you are getting first case condition, then immediately we should do cross multiplication. And each and every, then after that integrating on both sides, you can apply IBS each and every term, then apply integration, we are getting solution. This is what non-homogeneous equation first case model. Now coming to second case. See here, I hope all of you understood. Listen carefully. You know, basics is very important, Nana. So first, you can observe for procedure what? What is order? Order definition what? Order problem, how can you identify? A differential equation is given. The highest derivative is nothing but highest derivative of given differential equation is called a order. So how can you identify? And the degree. Degree means that the given differential equation is a polynomial or not. If it is a polynomial, it is okay. If it is not a polynomial, and we should modify it to natural number form. Then in degree, that time we should observe every problem. We should observe what are every derivatives should not have the function of exponential or trigonometric or logarithm functions are there. That time degree is not defined. Okay. And variable separable, already we know that a differential equation of the form is look like f of x into dx plus g of y into dy equal to 0 is there. Then immediately we should do and integrating on both sides, then solving, we are getting answers. So based on that, we are getting so we got some problems also completed. Now coming to homogeneous differential equation means a differential equation of the form is look like dy by dx is equal to f of x comma y by g of x comma y, where f of x comma y comma g of x comma y are two functions. Okay, so based on at the same time degree also should be equal, Nana. Okay, should be equal, same degree only. So in this we have two cases, Nana. One case is whenever given differential equation is dy by dx form is there, immediately we should do put working rule is put y is equal to vx. Then derivative we are getting dy by dx is equal to v plus x into dv by dx. The two values substitute in given differential equation, then simplify. After that we are getting v terms and x terms, Nana. So then we can write variable separable means v terms one side and x terms one side. Then we can write integrating on both sides, then simplify, we are getting answer. Okay, so the previous question also very lengthy, you can try. If you are not getting, I will tell you that previous one, homogeneous, first problem. And second in second problem is second case. So whenever a differential equation of the form is look like dx by dy equal to f of x comma y by g of x comma y is there, and same degree means it is also homogeneous differential equation, but working rule is different, Nana. So that is what, put x is equal to vy, put x is equal to vy, put x is equal to vy. Then we should derivative with respect to y only, means dx by dy plus dx by dy plus equal to v plus x into dv by dy. Okay, the two values substitute in same given differential equation, then simplify, variable separable, then integrating on both sides, then we'll get answer, none. So non-homogeneous is the first question is completed. Now coming to in non-homogeneous case 2 model question, right? Case 2 model one question. The solution of differential equation, the solution of differential equation dy by dx, the solution of differential equation, the solution of differential equation dy by dx, dy by dx equal to x plus 2y minus 1 by x plus 2y minus 1 by x plus 2y minus 1 by 2x plus 4y, 2x plus 4y, 2x plus 4y plus 3 plus 3. So it is a non-homogeneous equation. How can you know? Already we know that the standard form of non-homogeneous equation is represents what? dy by dx is equal to ax plus by plus c by a1x plus b1y plus c1. Okay, so that is look like this only, na? So first we should observe here a equal to 1, b equal to 2, c equal to minus 1, and a1 is equal to 2, and b1 is equal to 4, and c1 is equal to 3. So first we should observe it is a non-homogeneous equation, but this equation, this non-homogeneous equation is satisfy the case 1 or case 2 or case 3, we don't know. So depend on conditions. So first we should observe b equal to minus a1 is this condition is satisfied or not. First we should observe. Now that implies b. What is the value of b here? 2 equal to minus minus is as it is. Now a1, what is the value of a1 here? 2. So 2 is equal to minus 2. It is both are equal? No. So not equal to means Whenever b is not equal to minus a1 is there, we are going to second case or third case. So now one more condition, what? A by a1 equal to b by b1. Okay. So that implies now a by a1 is nothing but a is 1 by 2 equal to b is nothing but what? 2 by 4. 2 by 4. 2 ones are 2 twos are. See. So LHS is equal to RHS. LHS A by A1 value is 1 by 2. B in RHS also 1 by 2 is there. This problem, this non-homogeneous equation is belongs to which case? Second case. So second case working rule what? Now I am writing equation. This is 1. Now equation 1 becomes, I can write equation 1. Equation 1 dy by dx equal to x plus 2y minus 1 by, listen Anna carefully, working rule just to, I can explain one problem. Every problem you can do same like this only. Now in this we should take 2 is take common, x plus 2y plus 3. So already I have told just now, repeated term is there. Numerator is x plus 2y and denominator also x plus 2y is there. Now we should take here, we should take now x plus put x plus 2y equal to some t or v, your wish. Now I am taking what a t. Now differentiate with respect to x. Now what you will get, d by dx of x value is 1 plus 2 into dy by dt, that equal to dt by dx. Okay. So we want dy by dx value. So that's why I can write directly dy by dt is equal to, can I write 1 by 2 into dt by dx minus 1. So by using these two values, we should substitute in this. Now what you will get now, dy by dx, sorry, in place of dy by dx what? 1 by 2 with respect to x, no? With respect to x, dy by, one second. So 2 into dy by dx equal to dt by dx. Now dy by dx equal to 1 by 2 into dt by dx minus dt by dx minus 1. dt by dx minus 1. Now I am writing, given equation becomes, in place of dy by dx, I can write this 1 by 2 into dt by dx minus 1, that equal to t minus 1 by 2 into 2t plus 3. 2t plus 3. Now I am writing this 2, I am sending to here, dt by dx minus 1 equal to, this 2 is multiplied here. What you will get now, 2t minus 2 by 2t plus 3. Now minus 1 I am sending to here, dt by dx equal to 2t minus 2 by 2t plus 3. Now plus 1. Okay. So I hope all of you understood now this part. So just listen. Now dt by dx equal to, now take LCM 2t plus 3. Now 2t minus 2 plus 2t plus 3 by now 2t plus 3. Okay. Now dt by dx equal to, so 2t plus 2t is nothing but 4t plus 1 by 2t plus 3. 2t plus 3. See, after doing, we are doing what here? Variable separable. Variable separable means all t terms, all x terms. Okay. Can I write 2t plus 3 by 4t plus 1? 4t plus 1. 4t plus 1 into dt equal to dx. Now integrating on both sides. Okay. Integrating on both sides. Now integral of 2t plus 3 by 4t plus 1 into dt equal to dx. Integral of dx. Now we should multiplying and dividing with 2. I can write 1 by 2 into 4t plus 6 by 4t plus 1 into dt equal to integral of dx. Listen and carefully. Based on denominator only, we should modify to numerator. In denominator is 4t is there. In numerator 2t. So we want 4t. That's why I can do multiplying and dividing with 2. Then the 2 is multiplying with the numerator. 2 into 2t is nothing but 4t plus 2 3 is a 6. We are getting this step. So after this, I hope all of you understood this part. Okay. Now coming to this part. Now 1 by 2 into integral of 4t plus 1 by 4t plus 1, 41 plus 5 by 4t plus 1. So in numerator, we can write 6 can be written as 5 plus 1. Okay, 5 plus 1 is 6 only, take LCM, we are getting same only. Now that is equal to integral of dx. Okay, now see, listen Anna, here both terms will be cancelled. Now integral of, listen carefully. Now 1 by 2 is as it is 1 by 2 into integral of 1 into dt is t. Now plus integral of 5 is take outside, 5 by 2 take outside, log means 1 by 4 only. Now log of 4t plus 1 and RHS is what here 4t means this is the t by 1. So t by 1 directly you can write, don't no need bracket. So this is what t by 2. Okay. T by 2 that is equal to integral of dx means x plus c. So t in place of t you can write x plus 2y by 2 plus 5 by 8 log of mod 4 into x plus 2y plus 1 equal to x plus c. Okay. Now here this is the solution of given non-homogeneous differential equation. So listen and carefully, every problem that is EAMCET or mains or everything, first basic procedure is important. Okay, procedure is main important. So whenever in non-homogeneous first case model, how to do, just we should do cross multiplication, then apply integration on both sides, then we are getting answer. And second case is based on conditions, b equal to b is not equal to minus a1 comma a by a1 equal to b by b1 is there. So that time we should take some repeated term. We have to write repeated term only. We should take t or v, then derivative, then given integral, given differential equation becomes substitute, then simplify. We are getting like this. Now one more is a third case model. Third case, one important the previous question only. This one, listen. The substitution of, I hope all of you understood now. So coming to another question type in case 3 model. Right. In case 3. So in question is what asking. Just look at the question. The substitution required to change the 3y. Third question. Now 3y. The substitution required to change 3y. 3y minus 7x. 3y minus 7x plus 7, 3y minus 7x plus 7 into dx plus 7y minus 3x, 7y minus 3x plus 3 into dy equal to 0 is given. Equal to 0 is homogeneous differential equation. In this case, we have how many options are there? We'll see. 4 options are there. Which one is correct? We can check here. Small x is equal to capital X plus 1 and small y equal to capital Y. First option. And second option is x is equal to capital X and y equal to capital Y plus 1. And third option is x is equal to capital X plus 1 and small y equal to capital Y plus 1. And fourth option is small x is equal to capital X plus 2. Okay. And small y equal to capital Y plus 2. Capital Y plus 2. So based on this is a non-homogeneous equation, third case. Just based on options, this problem is belongs to third case only. But how to do procedure? Okay. Now we should take first by using these two lines. We should take this is the first line. This is the second line. Okay. Now 3y minus 7x plus 7 equal to 0. That is equation 1. 7y minus 3x plus 3 equal to 0. That is second equation. Now we should take working rule what? Put small x is equal to capital X plus h and small y equal to capital Y plus k. Okay. So now I can write in place of y I can write capital Y plus k. Now substitute in this, then simplify. What you will get now? 3y plus 3k minus 7x, 7 into capital X minus 7h plus 7 equal to 0. Okay, now I am writing so minus 7x plus 3y. HK terms take LHS only. I can write minus 7h plus 3k and plus 7 equal to these two x and y terms sent here. 7x minus 3y. And one more step, this one is I can write 7y plus 7k minus 3x minus 3x minus 3h plus 3 equal to 0. Here also you should write. This is the one of the shortcut how to put x, h and k values. Okay. Now I can write so h and k terms write in LHS minus 3h plus 7k plus 3 equal to plus 3x and minus 7. Okay. So whenever if you are finding h and k values, these two values taken as zeros. Okay. Now this is equation 1 and 2. Na? So we should eliminate what? We should eliminate. So first equation. This is taken as first only. This is the second only. Okay. So first equation I can write multiply with the first equation is multiply with the 3. Okay, what you will get now that is equal to first equation. First equation is multiplying with the 3. First equation is multiplying with the 3 minus second equation is multiplying with the 7. So what you will get now here? So minus 21h plus 9k plus 21. So minus minus into minus plus 21h 21h plus minus 7 sevens are 49k. Okay, now plus minus 7 3s are 21 equal to 0. Now 21h is cancelled. 9k and means minus 40k now. Minus 40k and 21 and 21 is cancelled. So what you will get 0. Then k equal how much? 0. Now k value substitute any equation. We are getting h value. H is equal to k value 0. Now h is equal to I can write 1. H is equal to 1. Now, so answer is small x is equal to capital X plus h. Capital X plus h means in this capital X plus h this one and y means 0. Na? So first option is correct. So whenever a non-homogeneous equation is given, especially in third case, model questions look like this only. In EAMCET or mains or advanced also same like this only. Just we should do only these two equations, then substitute. Put x is equal to capital X plus h and y equal to capital Y plus k. Then substitute in this. We should terms are negligible terms. We should take x and y terms. Take x capital X and capital Y. Now choose hk values based on we should solving the two equations. We are getting h and k values. All values substitute in equation on 1 and 2. We are getting what here equation h terms are having what this is the equation 1. This is 2. This is sorry. This is 1 and 2. This is 3 and 4. We can take like this. So this is what here 2. sorry, 3. This is what here 4. Okay. So after that, we are getting this answer, right? So this is the one of the question, Nana. So this is a non-homogeneous differential equation is based on case 1, case 2, case 3 problems completed. Okay. Now coming to linear differential equation. I hope all of you understood now. So every problem you can do same like this only. Okay. Now now linear differential equation. Linear differential equations. See, linear differential equation means a differential equation of the form dy by dx plus py equal to q, where p and q are functions of x or constants only. So this integrating factor equal to e to the power of integral of p dx. This is the integrating factor. First step one is it. And second step one is general solution means y into integrating factor equal to integral of q into integrating factor into dx plus c. So whenever a linear differential equation is given, this is what here linear in y. We can say in this is the linear in y. Okay, this is linear. In linear differential equation, this is a linear in y means how can you identify linear in y or linear in x? Linear in y means dy by dx, and at the same time RHS value should be in terms of functions of x or constants only. P value also. Okay. Now case linear in x. Linear in x. Linear in x means dx by dy, a linear differential equation dx by dy plus px equal to q form is there, where p and q are functions of y are constants only. Y are constants only. Now in this first point is integrating factor it in e to the power of integral of p dy. Okay. And general solution means second one is general solution x into integrating factor equal to, okay, integral of q into integrating factor into dy plus c plus c. So these two are two cases in the linear differential equation, linear in y and linear in x. Okay. So based on each step one, step down, we can do what one or two questions, and linear in x also we can do one or two questions. See. Now first one is see now integrating factor. Integrating factor. I hope all of you understood, Nana. I hope all of you understood. So just 1 second, listen. Problems. Each case one problem. Right. First one in linear in y based on linear in y or linear in x is we don't know. So how can you identify based on question? After writing question, just you only say. Okay. Right. Integrating factor of factor of x log x, integrating factor of x log x into dy by dx, integrating factor of x log x into dy by dx plus y equal to 2 log x, y equal to 2 log x. Yes, listen Anna carefully, all of you listen carefully. See here, it is a differential equation, a linear differential equation, but in linear differential equation, we have two cases. Now, first one is linear in y and second one is linear in x. Sir, how can I identify, sir, linear in x or linear in y means? First, we should observe dy by dx. dy by dx is there, immediately you should observe RHS, x terms and with the constants. Listen Anna carefully. Linear in y means dy by dx term. At the same time, RHS value should be in terms of functions of x with the constants. So those the then the differential equation is a linear differential equation in linear in y. Now, first linear differential equation linear differential equation linear in y means what? That is look like dy by dx plus py equal to q form. Okay. Yes, I'm correct only, na? Dy by dx plus py equal to q. It is clear. So, actually, in formula dy by dx coefficient is how much? 1 is there. But in this dy by dx coefficient, how much here? X log x is there. So, we don't want x log x value. Okay. So, now we should do what? Dividing by x log x on both sides. X log x on both sides. Now what you will get now dy by dx plus 1 by x into log x, 1 by x into log x into y equal to 2 log x by x log x. 2 log x by x log x. Listen Anna carefully. See, whenever one linear differential equation is given, first of all we should observe that is a linear in x or linear in y. Linear in y, how can you know? Dy by dx in RHS, immediately we should observe RHS x with constant terms or x terms are there immediately. Yes, it is a linear in y. In linear differential equation, it is a linear in y. After confirmation, dy by dx coefficient should be 1 only. But in this, some function is there, x log x is there. So we don't want log x log x. So that's why I'm doing dividing by x log x on both sides. We are getting dy by dx plus py is equal to q form. Now we should compare to this one. Now p is equal to 1 by x log x and q is equal to log x is cancelled 2 by x. Okay, log x is cancelled. Now 2 by x. Now actually we want to what integrating factor is asking. In question is what asking? Integrating factor. Integrating factor formula what? E to the power of integral of p dx. Integral of e to the power of integral of p dx. Now that is equal to I am writing e to the power of integral of p means what? 1 by x log x into dx. Integral of e to the power of integral of x 1 by x log x is given. Already have told previous class. So integral of 1 by x log x is log x formula is not there. So whenever one integral function is given, first of all we should identify 2 points, Nana. 3 points, actually 3 points. First and second and third. So whenever one integral is having one function is there, immediately we should observe direct formula is possibility is there or not there. First condition. So not there here. Then go to second. Second is nothing but whenever one integral is having two functions, we have to do method of substitution. Method of substitution means that integral is having should be two functions only. Now here, observe here. 1 by x is a one function, log x is one more function. So substitution method means we are here in this which function taken t after derivative we are getting a second function. That is what here method of substitution. Now I am taking here put log x is equal to t. Log x is equal to t. After derivative we are getting what 1 by x into dx equal to dt. Now given integral becomes e to the power of integral of 1 by, so x into dx, see listen Anna carefully. See 1 by, see log x is equal to taken as t only, 1 by x into dx is nothing but what? I can write 1 by t. 1 by t. 1 by t into dt. Okay. Now that is equal integral of e to the power of integral of log 1 by t, 1 by x into dx what? Log x. Means log t. Now that is equal to t. Now that is equal to t. What is the value of t here? Log x. So that is what here log x. Okay. So once again I'm reading. How can I read this one? This part of just listen. Some students are having doubt here only. See, I can write this one can be written as integral of 1 by x into dx into 1 by log x, Nana. Okay. So this is the, if you are taking log x is equal to t, after derivative we are getting this part only, na. So instead of that, I can write what here dt. Now 1 by log x, can I write what here t only? Why? We should take what here log x is equal to t. After substitution, we are getting this step. So this is what integrating factor. So in linear in y, how to calculate integrating factor? First, we should observe it is a linear differential equation should be. It is linear in y or linear in x. How can you decide? Based on dy by dx. dy by dx there, immediately we should observe in RHS x function is there or not there. If it is there, yes, it is a linear in y. But linear in y means dy by dx coefficient is 1 only. But here some function is there. We don't want that function. So dividing by x log x, then convert dy by dx plus py is equal to q, then find out p and q value, then substitute in equation, substitute in formula, then we'll get answer. This is a linear in y, just integrating factor. Sometimes general solution is asking how to calculate general solution. So right here one question is a linear differential equation general solution based and integrate in this word we should calculate step 1 and step 2 and the first point and second point. Right, that question, second question, right? Yes, I hope all of you understood now. Yes, I hope all of you understood now, Nana. So, right, question. Now, problem number 2. Right, problem number 2. Right, problem number 2. So, problem number 2. Solution of dy by dx. Solution of dy by dx. See, so whenever in question solve or solution is asking, we have to find out integrating factor as well as general solution only. Means, see, solution of dy by dx, dy by dx plus dy by dx plus 2y, 2y equal to e to the power of minus x, e to the power of minus x. Listen, Anna, carefully. Now, before that, it is a linear differential equation. It is clear. Linear differential equation, how can you know? First order derivative. Okay. So, linear differential equation is having two cases. One is linear in y and one more is linear in x. So, linear in y means here dy by dx, and immediately we should observe RHS what? X function is there. Yes, it is a linear in y. So, linear in y, after confirmation, immediately we should observe dy by dx coefficient should be 1 only, but here 1 is there, no issue, not a issue. Directly we can write here p is equal to, and means I am writing here, this will look like dy by dx plus py is equal to q. dy by dx plus py is equal to q. Now I am writing here p is equal to 2. So already I have told linear in y means a differential equation of the form dy by dx plus py equal to q, where p and q are functions of x or constants only. So here p is equal to 2 and q is equal to what? E power minus x. E power minus x. Now we should find out integrating factor e to the power of integral of p dx, that is equal e to the power of p is nothing but 2, take outside into dx, that equal to e power 2x. Integral of dx is nothing but x only. So before 2 is there, 2x. Now we should do what here? General solution means y into integrating factor equal to integral of q into integrating factor into dx. Okay. Now substitute in this, we are getting answer y into integrating factor e power 2x. Now q is nothing but e power minus x, e power 2x plus e power 2x into dx. Now I am writing y into e power 2x equal to base the same power should add e power x into dx. Now I can write y is equal to e power 2x equal to e power x plus c. Now I can dividing this one only solution. Okay. If you multiply also, no, not a issue. So that is the solution of this linear differential equation in y. Okay. Copy it now. All of you see. This is linear differential equation, linear in y. Yes, this is a linear differential equation. Linear differential equation. This is the first case, linear in y, how to calculate integrating factor and general solution. Now coming to linear in x, how can you identify linear in x? I hope all of you understood now. Say yes. See. Yes, listen and careful. I hope all of you understood now. Yes, now coming to one more question. See, that is uh, right question number. Right, the general solution of the general solution of the general solution of differential equation dx by dy dx by dy, the general solution of dx by dy plus the solution of the general solution of the general solution of dx by dy dx by dy plus x by y equal to x by y equal to x square. X by y equal to x square. See, listen, Anna, it is a linear differential equation. Sir, first linear differential equation means this is a first order differential equation. So that's why it is a linear differential equation. Okay. So linear differential equations are mainly two types. One is linear in y and a linear in x. So linear in y and means linear in x, this one. Linear in x. Linear in x, immediately we should observe in RHS what? X square is there. Linear in y. So the problem is taken. Sorry. So I can explain one more question. See, that is the wrong problem. So coming to this one, see. The solution of dx by dy, the solution of dx by dy, the solution of dx by dy, dx by dy plus 2y into x is equal to 2y. X is equal to 2y. So it is correct only. Yes, here. So it is a linear in x. Linear in x, immediately we should observe RHS. RHS, y function or x function? Y function. So whenever in linear in x, where p and q are functions of y are constants only. And that means it is look like dx by dy plus px is equal to q form. Okay. So where p is equal to functions of y are constants. And here p is equal to what? 2y. And q is equal to what here? 2y. Okay. P is equal to 2y as well as q is also 2y. Right. Now integrating factor. Integrating factor e to the power of integral of p dx. P dx or p dy, p dy. Why? Because p and q are in terms of y only. Na? So now I am writing e to the power of integral of p means 2 is take outside y into dy. Okay. So that is equal e to the power of 2 into y square by 2. 2 is cancelled e to the power of y square. So integrating factor of given linear in x is e to the power of y square. Now general solution. General solution means we know that x into integrating factor. X into integrating factor equal to integral of q into integrating factor into dy. Into dy. Okay. Now x into integrating factor value what? Integrating factor how much we got here? E to the power of y square equal to integral of q. What is the value of q here? 2y into e to the power of y square into dy. Into dy. Yes, just the substitution part is over, Nana. So now coming to here, now direct integration is not possible. We have to use method of substitution. Method of substitution means here 2y is the one function, e to the power of y square is one more function only. But if you are taking e to the power of y square is after derivative e power y only. So that's why I'm doing here. Y square is taken as t. Now I'm taking put y square is equal to t. Now differentiate with respect to y. Now 2y into dy is equal to dt. Okay. Now given integral becomes e to the power of x into e to the power of y square equal to integral of 2y into dy. Can I write what a dt e to the power of t. Now x into e to the power of y square equal to e to the power of integral of e power x into integral of e power x into dx is e power x only. So e power x formula what? E power t plus c. Now x into e to the power of y square equal to e to the power of in place of t. After evaluating this integral of function, we can substitute the back value of t is what here? Y square. So that's why I can write y square plus c. So this is the solution of linear in x. Okay. So in linear differential equation, so how to do integrating factor in linear in y, how to calculate integrating factor and general solution, and linear in x integrating factor means till up to here, general solution means that one. Every problem in EAMCET or mains also we can do same like this only. Okay. Now last one, Bernoulli equation, Nana. So last one is Bernoulli equation. Just listen, Nana, carefully. Bernoulli equation. Bernoulli's equation. See here, Bernoulli equation it is in the form of dy by dx, plus py equal to q into y to the power of n. See, actually linear differential equation means dy by dx plus py is equal to q, where p and q are functions of x are constants only, Nana. But in Bernoulli means here both RHS terms are functions of x as well as y functions. And it means whenever how can you identify it is a Bernoulli function or not? Depend on RHS only. RHS is always x and y function. And a q is x function, where p and q are functions of x in linear in y. But in RHS, what here both functions are x and y functions are there. So that time we should do what here q is a one function, y is also one more function. Okay. So now I am writing dividing by y to the power of n. So 1 by y to the power of n into dy by dx plus py by y to the power of n into q to the power of y to the power of n by y to the power of n. So both terms will be cancelled. Now I am writing y1 by y to the power of n into dy by dx plus p into y to the power of 1 minus n equal to q. So this is can be written as y to the power of minus n into dy by dx plus p into y to the power of 1 minus 1 n into 1 minus n by n equal to p. So this is the Bernoulli equation solution. We can do same based on problems. Okay, thank you. Doubts? If anybody have doubt, you can ask. Yes, I hope all of you understood now.